Alright, welcome back everybody. Since I had to rush through the end of example 1 of the slope of polar curves lesson so abruptly at the end last time, I figured I'd come back and take the time to finish it and give it ample time to look at what goes on with this where theta equals pi over 2 and what's going on there, because both dx d theta and dy d theta are 0. So we have that dy dx is equal to cosine of theta minus 2 sine of theta cosine of theta, and dx d theta is negative sine of theta plus sine squared of theta minus cosine squared of theta. And the limit of this, as theta approaches pi over 2, is 0 over 0. So how am I going to deal with that? I'm going to deal with that using L'Hopital's rule. And so I'm going to find the limit as theta approaches pi over 2, and now I'll just take the derivative of the numerator and the derivative of the denominator. So let's see, I've got negative sine of theta minus 2 times, and using the product rule, I've got sine of theta times negative sine of theta plus cosine of theta times cosine of theta. All of that over negative cosine of theta plus 2 sine of theta cosine of theta minus 2 cosine of theta negative sine of theta. So it's just going to turn into a plus. And so I'd like to find the limit as theta approaches pi over 2 of negative sine of theta plus 2 sine squared of theta minus 2 cosine squared of theta, all over negative cosine of theta plus 4 sine of theta cosine of theta. And if I find this limit as theta approaches pi over 2, let's see, what do I get? I get negative 1 plus 2 minus 0, so my numerator is 1, and my denominator I get negative cosine of theta, so that's 0 plus 0. So I get 1 over 0 when I try to find this limit, and what that tells me is it tells me that dy dx is undefined there. Since dy dx is undefined, this is going to be a vertical tangent at this point. So we have a vertical tangent at theta equals pi over 2, and so we'll substitute pi over 2 into the original x to find the equation for that vertical tangent. And if we put pi over 2 in there, we get 0. That tells us that there's a vertical tangent at x equals 0. And so there are all the vertical and horizontal tangents to this curve. If I wanted to, since I have a little bit of extra time that I would not have had otherwise, if I go over to polar mode and look at this curve, we've got the curve 1 minus sine of theta, and we're graphing it from 0 to 2 pi. We'll do pi over 30, and let's see, I'm just going to make this from negative 2 to 2. Should be enough to capture the whole picture. And if I look at this graph, you'll see various places. You can see horizontal tangents at the bottom and at the top of this graph. Those are the horizontal tangents, y equals negative 2 and y equals 1/4. You can see vertical tangents on the right-hand side. That's at x equals 3 square root of 3 over 4. And on the left-hand side, that's at x equals negative 3 square root of 3 over 4. And then right at the pole, where we had the one that we weren't sure, you can see that that comes down to a cusp point there, and so there's a vertical tangent to the curve there. Alright, that concludes example 1 in earnest with all of the details. So hopefully you watched the video that started example 1. If you didn't, go back and watch that, and then come back to this one for the riveting conclusion. It's kind of like watching the last episode of a TV series without having watched any of the previous episodes if you only watch this video. Anyway, see you guys. Have a great rest of your day, and I'll see you next time.